In the previous video, we have seen the concept of impact and we have seen how to solve the problem on the direct impact. Now, in the direct impact, there are two special cases. So, case one, you can see if you drop an object from certain height edge, so it will bounce and then it will achieve certain height, that is the edge dash. Okay. So, if you know the number of bounce, then we can determine what is the height after that bounce. So you can see here, the object is initially at height h. So it starts moving in the downward direction. It will collide with the ground and it will achieve certain height h dash after n number of bounds. So we can determine the h dash value from the initial value h and from the coefficient of restitution. So we should know this relation. Height after n bounds, we can determine by using the relation E is equal to h dash upon h bracket raised to 1 upon 2n. Okay. So here n, it means that total number of bounds. H dash, this is the new height or height after n number of bounds, and h is the initial height. And the value E, it is nothing but the coefficient of restitution. The second special case is we can determine the velocity of object after the rebound from the wall or from the ground. Okay. So you can see here the object is dropped, and when it reaches the ground, just before the collision, it has certain velocity. So this is the velocity just before the collision, it is the V. Okay. After the collision, the velocity of the object will reverse its direction and it will start moving with certain velocity Va dash. Okay. So Va is the velocity just before the impact and Va dash is the velocity after the impact. Okay. So this relation we can write the Va dash, this is equal to E into Va. So by using this relation, we can determine the velocity of any object after the rebound from the wall or from the ground. Okay. So actually this is the object A and this is the object B. But here B object, it is the stationary. So velocity of B before impact and the after impact, it remains same. It is the 0. Okay. So therefore we get this relation as Va dash is equal to E into V. Okay. So we should remember these two equations. Equation is E is equal to h dash upon h bracket raised to 1 upon 2n. Okay, so we can determine the height of an object after n number of bounds. And second equation is Va dash is equal to E into V. So we can determine the velocity of any object on rebound from the wall or from the ground. So let's solve two problems on the special cases. So for the first problem, so a ball is dropped on a smooth for the first problem. A ball is dropped on a smooth floor from which it bounces to a height of 4 meter. On the second bounce, it attains a height of 3 meter. Find the coefficient of restitution between the ball and the floor. Okay. So the condition given here is a ball is dropped from certain height. So this is the ground. So this height is given, that is the initial height. So h is equal to 4 meter. After the second bounce, it attains the height of 3 meters. So this is the first bounce and this is the second bounce. So after second bounce, the height attained, this is 3 meters. Okay. So we can determine this coefficient of restitution by the relation E is equal to h dash upon h bracket raised to 1 upon 2n. So here h dash value, this is 3 meter, h value is 4 meter, 1 upon 2, number of bounds, it is 2. So if you solve this, you will get the answer 0.866. So this is how we can determine the coefficient of restitution after n number of bounds. We should know the initial height and the final height. Okay, now refer the next problem. A boy throws a ball vertically downward from height 1.5 meter. He wants the ball to rebound from the floor and just touch the ceiling of the room. The ceiling height is 4 meter. If coefficient of restitution is 0.8, find the initial velocity of the ball when it was thrown. Okay, consider this is the ceiling of a room and this is the floor or the ground. Now condition given is a boy throws a ball with certain initial velocity. So let us take this velocity as a v, okay, in the downward direction. So the height from where the ball is thrown, it is given as a 1.5 meter. Okay, so from this, with the velocity v, ball will impact with the ground and then it will start moving again in the upward direction. Okay, so just before the impact, the velocity of the ball we can assume as a va, and just after the impact, the velocity is va dash. With the velocity va dash, ball will start moving in the upward direction and it should reach up to the ceiling. It means that with the velocity va dash as the initial velocity, ball needs to cover a distance of total height. It is 4 meter. Okay, so we should find out what is the velocity v, that is the initial velocity when the ball was thrown. Okay, so here we have to use the equation of motion and then we will use the equation for rebound. Okay, so first consider the motion. Let us take this point as a 1 and this point as a 2. Okay, so for the motion 1 to 2, we have the initial velocity u as a va dash. Okay, total displacement s, it is 4 meter. The acceleration a, it is minus 9.81 meter per second square. So if you use the equation, v square is equal to u square plus 2as. From this we can determine the velocity va dash. So when it reaches at the final value 2 or position 2, the velocity it will become 0. Okay, so v is equal to 0, u value is va dash minus 2 into 9.81 into displacement is 4 meter. So if you solve this equation, the answer for VA dash, this is equal to, this is 8.86 meter per second. So this ball, it must have the velocity after impact that is equal to 8.86. Then it can cover the distance of 4 meter and it will reach to the ceiling. Now we have got the velocity after impact. Now VA is the velocity before impact. So we can use the rebound equation. So this is velocity just before impact. This is velocity after impact. For the rebound, we have the equation VA dash is equal to E into VA. E is given in the problem, which is a 0.8. VA dash is 8.86. This is equal to 0.8 into VA. So VA is equal to, this is 11.074 meter per second. So this is the velocity of the ball just before the impact. This is the velocity just after the impact. Now we have to find out the initial velocity with which the ball was thrown in the downward direction. Okay. Now you can use again the equation of motion. Now by using the equation of motion, so this is the velocity V. This is the velocity object reaches the ground. So VA. This distance, this is 1.5 meter. Okay. Now consider this position as a 1 and this is the position 2. So for the position 1 to 2, the initial velocity, this is V. Final velocity, this is VA and this is equal to 11.074. Acceleration is positive. This is 9.81 meter per second square. And displacement S, it is 1.5 meter. Now use the equation V square is equal to U square plus 2AS. So V, this velocity is 11.074. U value is unknown, which is V square plus 2 into 9.81 into displacement is 1.5. So from this we will get the velocity V. This is equal to 9.65 meter per second. It means that if you throw the ball with this velocity 9.65 meter per second from this position, then the object will rebound and it will reach to the ceiling height, that is a 4 meter. So this is the combination problem where we have to use the impact equation and the equation of motion. Now the second type or the second category in the impact is the oblique impact. So we have already seen what is meaning of oblique impact. In case of oblique impact, the velocity direction before impact and the after impact, they are not directed along the line of impact. So they are at an angle theta with the line of impact. So let us solve the problem on the oblique impact. Refer the first problem. So in the problem, two identical balls A and B approach each other with the velocities as shown. Determine the magnitude and the direction of the velocities of each ball after the impact. So the diagram is already given in the problem. So we will get the idea about the velocity direction before impact. So the mass given, but both the spheres have the identical masses. So we can take MA, this is equal to MB. So let us assume this as a M. Now the velocity before impact for the object A is 12 meter per second. So this is the net velocity VA. This is the VB, which is 18 meter per second. For the oblique impact, the steps are almost same. The first step is we should use the conservation of momentum equation. Now to use the conservation of momentum equation, we have to resolve the velocities before impact. So resolve this velocity along two direction. Okay. So the direction which is along the line of impact, this is called as a normal direction. And the perpendicular direction to the line of impact, so this is called as a tangential direction. Okay. So resolve the velocity along n direction and the t direction. So this angle is 45. So therefore this angle is 45 degree. So this component is VAN, which is a normal component. And the component which is parallel to the tangential direction, this is called as a VAT. Similarly, resolve the second velocity along normal and tangential direction. This angle is 70 degree. So this is VBN and this component is VBT. Okay. Now in case of oblique impact, always remember the tangential component of velocity, which is VAT and VBT, they will remain same before impact and after impact. So VAT is the before impact and VAT dash is the after impact. Similarly, VBT is equal to VBT dash. Okay. So this velocities component will remain same. Only we have to find out the normal component after impact. For that, we will use the conservation of momentum equation and the coefficient of restitution equation. Okay. So conservation of momentum equation for normal direction only, for n direction. So this equation will be mass of A into velocity of A in the normal direction before impact, mass of B into velocity of B, n. This is equal to, after impact is mass of A, velocity of A dash plus mass of B into velocity of B n dash. So this n dash is velocities after impact. Okay. So if you draw the diagram before impact and the after impact, so you can see here, this is the exact contact point, that is the point of impact. This is the direction of the velocities before impact. So this is a VA and this is the direction before for VB. Okay. After impact, you can see the direction like this. So this is VB dash, that is the net velocity after impact. And this is the VA dash, which is the net velocities of A after impact. Okay. So this velocities has two components. So this component is VAN, this component is VAT before impact. Similarly for B, this is normal component and this is a tangential component. So this is VBT and this is VBN. Okay. Similarly, velocity after impact will have two components. So this component is normal component. So this is VBN dash and this is VBT dash. A will have two components. This component is VAN dash and this component is VAT dash. Okay. Out of this, two components will remain same. So this component VAT dash, this is equal to before impact VAT. Second component of B, VBT dash, this is equal to VBT. Okay. Only change is in the normal component. So here normal component AN dash, it will change to AN before impact, and normal component VBN dash, it will change compared to VBN, which is the before impact. Okay. So conservation momentum equation is only used for the normal direction. So this is the first step. Second step is we have to use the coefficient of restitution. E is equal to V B n dash minus V A n dash divided by V A n minus V B n. This is the difference in velocities after impact, and this is the difference in the velocities before impact. Okay. Now here we can find out this component VAN and VT. So VA, this value is given, this is 12 meter per second, and its angle, this is 45 degree. So VAN, which is the adjacent component, so this is equal to VA cos 45. So this component, this is 12 cos 45, and direction is towards it. VAT, this is VA sin 45. So this is equal to 12 sin 45. Direction is positive y direction. Similarly for VB, VB is given, so this is 18 meter per second, and its angle, this is 70 degree. So VBN, this is equal to, so this is VBN and this is VBT. So this is 18 cos 70, and direction is towards negative x direction, and VBT, this is equal to 18 sin 70, and it is towards positive y direction. Okay. Now use first equation, conservation of momentum for normal direction. So which is equal to MA VAN plus MB VBN, which is equal to MA VAN dash plus MB VBN dash. So mass of A is equal to mass of B. So identical masses. So you can put the value as M. So M is equal to VAN. This is 12 cos 45 plus MB is M. VBN is negative. So minus 18 cos 70. This is equal to MA is M VAN dash plus M VBN dash. So we can cancel out the M, it is common. So we get the relation as VAN dash plus VBN dash is equal to 2.33. So this is the equation 1. Now use second equation for coefficient of restitution. E is equal to V Bn dash minus VAN dash divided by VAN minus VBN. Okay. So E value, this is given in the problem. So this is 0.8. This is equal to VBN dash minus VN dash divided by VAN. So this is 12 cos 45 minus VBN is on the negative side. So it is minus 18 cos 70. So this is equal to VBN dash minus VAN dash divided by, so this minus minus plus, so the answer is 14.64 this is equal to 0.8. So do the cross multiplication. So from this we get the answer Vbn dash minus Vn dash. This is equal to 11.71. And if you write this as Vn dash minus Vbn dash, so this is equal to minus 11.71. This is equation 2. Okay. Now solve the equation 1 and equation 2 simultaneously. So we get the answer for Vn dash. This is equal to minus 4.69 meter per second. It means that 4.69, it is on the negative x direction. And Vn dash, this is equal to 7.02 meter per second. It is on the right side. Okay. So after collision, you can observe the velocity directions are changed. So this is the net velocity, Vb dash. This is the component in the normal direction, which is Vn dash. This is equal to 7.02. This is tangential component. It remains same. Vbt dash. This is velocity of A, that is the net velocity, Va dash. This is Van dash. And this is the tangential component, Vat dash. Van dash, this is equal to 4.69. Okay. So the final velocity, which is Va dash, this is equal to, in the square root, Van dash square plus Vat dash square, and Vb dash is equal to square root Vbn dash square plus Vbt dash square. Okay. Take 80 dash is equal to 80 and Bt dash is equal to Bt.